Last time we were working on this inequality, 2x squared minus 7x minus 6 is less than 2. So we found the endpoints. This one is negative, 7 minus the square root of 113 divided by 4. So 7 minus the square root of 113 is close to negative 1 when you divide it by 4. 7 minus that number divided by 4. So if we pick a number to the left of that, x equals negative 2 should be safe. It's pretty clear that 0 is in the middle interval because this number is negative and this number is positive. So we already tested x equals 0 in the middle interval, and we got a true inequality. So that means all of the numbers in that middle interval are solutions. So we'll go ahead and test x equals negative 2 in that inequality. So we get 2 times negative 2 squared minus 7 times negative 2 minus 6 less than 2. Okay, so now let's do the arithmetic. Negative 2 squared is 4. 2 times 4 is 8. And then we're subtracting negative 14, but that's the same as adding 14. And then minus 6 less than 2. 8 plus 14 is 22. 22 minus 6 is 16. But 16 less than 2 is false. So none of the numbers in that interval on the left from negative infinity up to 7 minus the square root of 113 over 4 are solutions. And then the interval on the right, 6 is bigger than that number. So when we replace every x in the inequality with 6, this time we get 2 times 6 to the second minus 7 times 6 minus 6 less than 2. 6 to the second is 36. 2 times 36 is 72. Minus 42 minus 6 is less than 2. 72 minus 42 is 30. 30 minus 6 is 24. And 24 less than 2, that is false. So none of the numbers from 7 plus the square root of 113 over 4 to infinity are solutions. Since the inequality is strictly less than, we exclude the endpoints. So graphically, we put a parenthesis at the endpoints, at each of the endpoints, and then shade everything in between. Okay, so the interval notation for the solution set is parenthesis 7 minus the square root of 113 over 4, comma 7 plus the square root of 113 over 4, parenthesis. This is the interval notation. And then the algebraic notation, we write the number on the left, 7 minus the square root of 113 over 4 is less than x, which is less than 7 plus the square root of 113 over 4. Okay, let's move on to another example. Okay, so this inequality, 3y to the second plus 4y minus 4 is greater than or equal to 0. One side is 0 already, so we can look for the endpoints by solving the equation we get when we replace the inequality with equals. So solve the equation, 3y to the second plus 4y minus 4 equals 0. The solutions are the endpoints of the intervals, and they divide the number line into separate intervals if they are real numbers. So we'll use the quadratic formula. A is 3, B is 4, C is negative 4. So y is equal to negative 4 plus and minus the square root of 4 to the second minus 4 times 3 times negative 4. And this is all divided by 2 times 3. Okay, then y equals negative 4 plus and minus the square root of some number, all divided by 6. So inside the square root, 4 to the second is 16, and we're subtracting 4 times 3 times negative 4. So that is 16 minus negative 48, which is the same as 16 plus 48. 16 plus 48 is 64. So we got a nice square root of a perfect square this time. So we'll write this as y equals negative 4 plus and minus 8, all divided by 6. Okay, so one of the solutions is negative 4 minus 8 divided by 6, or negative 12 divided by 6, or negative 2. And another, I'll go ahead and we can tell that one of the endpoints is negative and the other one is going to be positive. So I'll go ahead and plot the number negative 2. The other solution, y equals negative 4 plus 8 divided by 6, is positive 4 over 6, or positive 2/3. So 2/3 is between 0 and 1. So those two numbers divide the number line into 3 separate intervals. And just like we've been doing, we pick a test point from each interval. On the left, pick a number less than negative 2. So I'll pick y to be negative 3. So when you replace every y with negative 3, well, we get 3 times the number negative 3 squared plus 4 times negative 3 minus 4. The inequality is greater than or equal to 0. Okay, now we'll do some arithmetic. Negative 3 squared is 9. 3 times 9 is 27. And then we're adding negative 12, so 27 minus 12 is 15. 15 minus 4 is 11. 11 greater than or equal to 0 is true. So yes, all of the numbers from negative infinity to negative 2 are solutions. Then in the second interval, we can pick y to be 0. Okay, that one is usually a nice number to pick for a test point. When you replace y in the inequality with 0, we get negative 4 greater than or equal to 0, and that's false. So none of the numbers between negative 2 and 2/3 are solutions. And then in the third interval, I'll just pick y to be 1. And then we can almost just tell by looking, if you replace every y with 1, 3 times 1 squared is just 3, plus 4 times 1 is 3 plus 4 is 7. 7 minus 4 is 3, and 3 greater than or equal to 0 is true. So yes, all of the numbers from 2/3 to infinity are solutions. Okay, remember the endpoints. Those are the numbers that are solutions to this equation when it's set equal to 0. So those two numbers are what make the left-hand side of this inequality 0. And 0 greater than or equal to 0 is true. It's the or equal to 0 that makes it true. So the endpoints are included, and graphically we put a bracket at negative 2, and then shade to the left if we're graphing the solution. Then we put a bracket at 2/3 and shade to the right. Okay, I used up all my space, so up here I'll write down the interval notation. This part of the number line is negative infinity, comma, negative 2, bracket. And then we put the union symbol, and the other part is bracket 2/3, comma, infinity. That's the interval notation for the solution set. And the algebraic notation, this part of the number line, y is less than or equal to -2. And then we write the word or, y is greater than or equal to 2/3. That's the algebraic notation. Okay, the last example, well, this one is a mess to start with. X plus 4 times x minus 2 is greater than or equal to 7. So we have to multiply the two binomials on the left-hand side and simplify, and then afterwards subtract 7 from both sides. So we'll go ahead and multiply the two binomials. We get x to the second minus 2x plus 4x minus 8 greater than or equal to 7. We'll go ahead and combine the like terms. The minus 2x plus 4x is plus 2x, and we'll also subtract 7 from both sides. So we get x squared plus 2x minus 15 is greater than or equal to 0. Well, this is going to turn out pretty nicely because when we look for the endpoints, first we set the quadratic expression equal to 0, and then we solve this equation to find the endpoints. And this factors really nicely. X plus 5 and x minus 3 are the two factors. And so the two solutions to this equation are -5 and +3. Okay, so we can plot those numbers on the number line, -5 and 3. We have 3 intervals to test. So in the first interval on the left, we can pick x to be -6. You're free to use any one of the inequalities. We have 3 inequalities to choose from, but sometimes when you have factors, those are sometimes nice to work with. So let's use the original inequality, replace every x with -6. So in this binomial, -6 plus 4 is -2. In the other binomial factor, -6 minus 2 is -8. And greater than or equal to 7, well, -2 times -8 is +16, and 16 greater than or equal to 7 is true. So that means, yes, all of the numbers from -infinity to -5 are solutions. In the middle interval, we can pick x to be 0. And so this time, a more convenient inequality when using 0 as a test point is this one right here. So replace every x with 0, we're just left with -15 is greater than or equal to 0, but we know that's false. So none of the numbers in the middle interval are solutions. And then finally in the third interval, pick a number greater than 3, so I'll pick 4. And I'll use the factored form first. So replace x with 4. In the first factor, 4 plus 4 is 8. In the other one, 4 minus 2 is 2. 8 times 2 greater than or equal to 7. Well, that's obviously true because 16 is greater than 7. So all of the numbers from 3 to infinity are solutions. And once again, we do include the endpoints because of the or equal to part. So we have a bracket at -5, shade to the left, bracket at 3, shade to the right. The interval notation, negative parenthesis, -infinity, comma, -5, bracket, union, bracket 3, comma, infinity. And then the algebraic notation, the variable is x. So this part of the number line, x is less than or equal to -5. And then we write the word or, x is greater than or equal to 3.